Hey guys, what's up? Welcome to the latest video lecture of STAAD PRO classes. Up to now, we have already given the support fixed end support conditions, that is the fixed ends. Now let's move towards the load definition. The most important part is the load definition. So for load definition, you need to go to this load and definition tab. Now at first what you need to do is add load cases details. You can see three things: definitions, load case details, and load envelopes. You need to go to the load cases details, add, and then you will be finding these things. So number, the serial number, then the title, what you want to give, and the loading time. That is, there are various kinds of load. So the first thing you go for is now let's start up with the dead load only. That is the dead load, and give it as DL. Add. Then today we will only go for dead load and live load. In the subsequent lectures we will go for the various things. Now the dead load and then the live load, let us name it as LL. Add, close. Now how to go and add for the dead load? In order to add the dead load is actually for the all the means members in the beams there is dead load. So you must be knowing about the various characteristics of the dead load. So in order to add the dead load, what you need to do, select dead load, add self weight. Dead load is what? Self weight, and it is in negative y direction. So add, close. Now what you need to do, self weight is assigned to all the members of the means all the members of the beams and columns. So for that what you need to do is assign to view, because it will be assigned to all. Assign, yes. So the self weight has been attached with each and every beam, because self weight will be coming to everybody. Fine. So after the self weight there will be some loads like the loads of the wall coming all over it, over the beams. So in order to, because those are also the dead loads, the loads of the wall coming over it, the finishing, the floor, the slab, these are all also the dead load. We haven't added the slabs and all till now. So for that what you need to do is DL, dead load only, this will be dead load only. Add, go for the because here just you see there are various conditions like various self means there is a self weight, the nodal load, the member load, the everything. So always go for this save. So for that one you need to go for the member load, and there will be uniform force. We are actually designing it for the uniform force. So uniform force, how much kilonewton meter? Let's go for first the walls. Walls are generally 15 kilonewton per meter in global y direction. Add. Then these are the main walls, and when the partial walls, the calculation I'll be showing you in the next class how it is 15 and all. But if you have the basic ideas, you will actually be knowing in this. We'll be discussing that in some next lecture, or what, how is this 7.5, this 15 and all, because those are just basic reinforced concrete design and all. It's just a basic things. This, add. Oh, one thing I had just forgotten. Okay, fine. The way I so this 7.5, but this 7.5, and then okay, let us add the beams. Oh, close. Delete. Now just see, I have added 7.5, but 7.5 will be in the negative y direction. So I need to edit it. In order to edit it, what I need to do is edit, give just a minus sign, change, close, and this one too, edit, give a minus sign, change, close. Now I need to assign this unit weight, this 15 kilonewton per meter, to all the beams in the outer section. Means what? I have to assign it in these outer walls. I have to assign all the 15 kilonewton meter. So see you in the next lecture.